Hello everyone, and hope you're fine today. Today's lesson is gonna talk about the experimental and theoretical analysis of an AC circuit. We're gonna study the capacitive circuit of an RC. It is constituted of a resistance and a capacitor connected to the oscilloscope in series. The objectives and competencies required are the following: connecting RC to an oscilloscope, and then we're going to study the experimental analysis through the graphical representation, determining maximum and phi, which is the phase angle, and then see the phasor representation. And then we're going to study the theoretical analysis, determining u of m and the phase angle, theoretically phi. And then we're going to take a practice exercise. Let us begin. We have here a given current, which is I equal I maximum sine omega t, such that the voltage of the generator is um sine omega t minus phi. And here we have minus here. This means that the voltage lags the current by an angle phi. Or we say U lags behind I by phi. So we have actually this circuit. We have a capacitance and a resistance. We connect the resistance with a phase component resistance and then the ground. And likewise for the capacitance, phase, capacitance, ground. So we have the resistor and the capacitor connected in series, such that we connect both of them to the oscilloscope. Always, whenever we want to connect any two components to an oscilloscope, we put the ground in between these two components, such that the rule says phase component ground, and here phase component ground. And the oscilloscope gives us actually this graph, such that the red graph represents u of r, and u of r is UAM. UAM such that the current goes here, entering into A, such that UAM is positive, and the current is entering here, M, such that it is the capacitance voltage, U of C, UMB. But since the oscilloscope reads phase component ground, this means that we have to invert it. So that's why we make an inversion to get a positive voltage. So the red one is the voltage of the resistance, and the blue one is the voltage of the capacitor. However, what do we want from them? We want to realize or determine which one reaches its maximum first. We realize that the red curve has reached first its maximum before the blue curve, which is for the capacitor. So the resistance, which is U of R, reaches at a certain time t1 its maximum before U of C reaches its maximum at time t2. This means that if U of R is the image of I, this means that U of R and I are directly proportional. So if U of R leads U of C, and U of R is the image of I, this means that by substitution U of R and I leads U of C. And we can say that I leads U by phi, or U lags I by phi. We're going to find phi and find UM as well. But first, let us do something here in order to know or to remind us about it, about the concept. So ice, as we have taken previously in an RL circuit, while we have Eli where U leads I. Here in the RC circuit, ICE where I leads U. I is leading the voltage by a certain angle phi, where the voltage lags I by a certain angle phi. When we say lags, it means minus phi. Based on that, we have proven this concept that we have taken that I leads U by phi or U lags I by phi from this curve or these oscillograms of the oscilloscope. Now, we want to determine phi, which is the phase angle at t0 equals 0, and we need to find U of m as well. Let us begin with the phi. We have known previously that to determine the phase angle, we have to apply a certain formula or a concept, which is 2 pi times x from 1 to 2 divided by t divisions. And 2 pi is one cycle. X from 1 to 2 from the first maximum or from the maximum of the first curve to the maximum, first maximum of the second curve, such that they are consecutive. They are necessarily consecutive. So actually that's x from 1 to 2, and usually we have it. Let's take it for now as an example, 2.3 divisions. If this is 2.3 divisions, we can just plug them in here. What about t divisions? It's about taking the number of divisions for a period. For a period, it is from peak to peak or from rest to rest. Okay? But here for the blue curve, we don't have peak here, so we take it for the red one from peak to peak. Let's say it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's take, this is 9 divisions, and if that is 9 divisions, in this case we can find phi. Of course, it needs to be in radians, and I will leave this for you to make the calculations. So that's for phi. Let us find U of m now, the maximum voltage for the resistance. How can we do that? It is SV1 times YM1 as we have taken it previously. So SV1 is the vertical sensitivity of the curve of R. So let's say SV1 is given to be 2 volts per division times, it should be given here 1, 2, 3, 4, 5, the maximum, that's the maximum Ym, it is 5, and thus we can find the maximum voltage. It's gonna be 10 in this case. Likewise, for the blue curve, it's the same. U of m of c is equal, the number of divisions is 7, Ym2, and SV2, maybe it is 2, maybe it is 4, and we can find it experimentally and from the curve. Now, as long as we have done that experimentally, let us do that theoretically. From what we know, that the addition of voltages law, which is a very important law we are using in physics, you have to use it here. U of t is equal U of r plus U of c. So actually U of t, that's the voltage of the generator, is equal U of c plus U of r. So let us go forward. So we substitute U of t by its equation. Um sine omega t minus phi is equal to Ri the Ohm's law for U of R is Ri, and U of C, it is Q over C actually. Okay? So what does that mean? It means that we are just applying the addition of voltages law. And because we are only using the addition of voltages law, we are substituting in the equation I is equal I maximum sine omega t here plus Q over C. Okay? Then we need to find Q here as sine or cosine. So we cannot put the equation like that. We need to find Q as sine or cosine. So we know that I is dq over dt, dqm. Why? We have talked about that in the RC circuit for the square signal, and we have talked about it in that chapter. Qm because the current actually is entering into M, so that's the positive terminal considered to be. dqm, so integrate both sides, crisscross. dqm is equal to I dt. So the derivative of both sides, we make integration. Q0 initial to Q, from I0 initial to I dt. And then we know that Qm is C U of C. So we substitute it here. So this means that I is d Cu over Cu C over dt. C will go outside and it will be C duc over dt. Thus, using this equation and I, this means that duc is equal to 1 over C I dt. And then we integrate both sides because this is a derivative, this is a derivative. duc from 0 to uc and from 0 to t of I. Now we substitute the function of I here, and we know that the integral of Im goes outside because it is a constant. Integral of sine is minus cosine. The derivative of sine is cosine, but the integral of sine is minus cosine. Why? Because the derivative of cosine is minus sine. Minus and minus will cancel out so that we get the same equation. And then we substitute this equation in the equation here. U of m sine omega t minus phi, because the voltage lags the current in an RC circuit, or the current leads the voltage in an RC circuit. So we have Rim sine omega t plus Q over C, and we have proved it to be minus Im over sine omega cosine omega t. Now we want to determine phi as we have determined it previously experimentally. Now we want to determine it theoretically. Using the first method, which is the trigonometric method, using this one, sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta, so C co C, such that the sine here is the same as the sine here. While if you want to take it, if it is cosine, it will be interchanged. The minus will be plus and the plus will be minus. So we substitute this equation, or we apply this equation for this equation. Um sine omega t minus phi, consider this is alpha, consider this is beta, and we substitute them having this equation. Um sine omega t cosine phi minus um is multiplied for both cosine omega t sine phi. So we'll get this equation, which is actually this one, that we have got, is equal to what we have already found. So we put them equal to each other, such that we know that here we have sine omega t, here we have sine omega t, so they are similar. So let's see what would happen. So we have sine omega t, sine omega t. So let's begin with the red one. So in the red one, cosine omega t and cosine omega t will cancel out. What remains is minus um sine phi is equal minus Im over c omega. So cosine omega t, they will cancel out. What remains, sine phi is Im over C omega over UM, and minus will cancel out. That's the first equation. What about the second equation? We have sine phi and here sine phi. What remains? UM cosine phi, and there we will have at the other end sine phi, sine omega t. Sine omega t, they will cancel out. UM cosine phi is equal RIM. So we will get cosine phi is RIM over UM. That's the second equation. So actually it's the same strategy that we have used in an RL circuit, but here we are using the RC circuit. So in order to have a tangent or sine or cosine, we have to divide 2 over 1. So sine over cosine will be tangent, and IM UM over C omega over RIM over UM. So we will get tangent sine phi over cosine phi is equal IM over UM C omega over RIM over UM. IM and IM will cancel out, UM and UM will cancel out. So we will get 1 over C omega over R. So all of it will be 1 over RC omega. So that's how we can find the phi. So phi is equal to tangent inverse of 1 over RC omega given the numerical values. Now we want to find U maximum. How can we find that? Square and add as the previous equations. We have these two equations. We need to square and add them. So in order to square and add them, we have, this is the first one, squared cosine UM here is here, UM cosine squared, UM squared cosine squared plus UM squared sine squared phi is equal to RIM all squared here plus I over C omega all squared. This implies cosine squared phi plus sine squared phi is equal to 1. So UM squared will remain. And here it will be as is, and then we can find U maximum taking IM squared to the outside. It will be IM square root of R squared plus 1 over C omega squared. However, there is another method we can use, which is particular values. So using particular values, which are omega t is 0 or omega t is pi by 2 radians. So using the equation that we have already found, let us substitute first omega t is 0 and see what would happen. So if this is 0, UM sine minus phi is equal to RIM sine 0. Sine 0 is 0, this will be cancelled out, is equal to minus, so what remains is this one because cosine 0 is 1. So minus IM over C omega, that's what we get. Sine minus alpha is minus sine alpha. So it's equal to, actually, that is omega t. Okay? And omega t is actually not 0, that's cosine. Okay? So we have here UM sine minus phi is equal minus UM sine phi, and it is equal to this because this will be 1. So minus IM over sine C omega, and then we will have minus and minus will cancel out. UM sine phi is equal IM over C omega. That's the first equation that we have determined. The second equation using omega t is equal pi over 2 radians. Let us substitute pi over 2 here. Sine pi over 2 minus phi. Sine pi over 2 minus phi is actually cosine phi from the trigonometry. So we substituted it, and then is equal to this equation. So this is sine pi by 2, which is equal to 1. That's equal to 1. And cosine pi by 2, this is 0. So this factor will be cancelled. 0 times anything constant, which is 0 actually. So what remains is UM sine pi by 2 minus phi. It is cosine phi by trigonometry. And what remains here, RIM. That's the second equation. From these two equations, we can square and add and get the same equation of U maximum. Knowing that, the homework and the direct application is practice exercise 1. The current I of t is equal 5 sine 40 pi t plus 0.8, of course, in radians. All of them are in SI units. Flows across a capacitor of capacitance 2.2 microfarad and the resistance of 2 ohms. So we have the capacitance and we have the resistance. We want to determine U maximum and the phase angle phi using two methods. I hope you enjoyed the lesson. However, I want to add something, that the power, what is this curve, the purple curve, which is power? This is the average power equation. The average power equation is actually UI, the voltage, times the current, times the cosine of the angle phi. We know that the voltage is in volts, the current is in amperes, and we know as well that phi is the phase angle. Okay, what about cosine phi? What is cosine phi? Cosine phi, it is called the power factor. The power factor. What do we mean by the power factor? I'm going to give you an example and you're going to conclude what is it. So the power factor is the factor that affects the average power. For example, if phi is 30 degrees, as phi increases, cosine phi decreases. As cosine phi decreases, power average decreases as well, because cosine goes from -1 to 1. For phi, for example, pi by 2. Cosine pi by 2 is 0. So the average power when phi is pi by 2 is 0. So cosine phi is the power factor that affects the factor of the power or the average power and so forth. That's why we're going to go for the special case, as we know that, and we have said that the current in an RC circuit leads the voltage by an angle phi, or the voltage lags behind I by an angle phi, which is minus phi. Knowing that, we're going to go to the special case of an RC circuit. In this case, the phi is pi by 2. And if phi is pi by 2, then we say that it is purely capacitive. Purely capacitive circuit RC. Purely capacitive means that R is 0. We only have a capacitor of capacitance C. Okay, so this is 0, so we only have a capacitor's voltage. Okay, and in this case, I leads U by phi, which is pi by 2 radians, or U lags I by phi, which is minus pi by 2. So whenever we have lags, we have minus. Whenever we have leads, we have a plus here. So it's the same idea from previous, such that now I'm gonna concentrate on something here on the phasor. So what do we mean by the phasor? Phasor is whenever you have UC here and U of R here, we have a current. So that's another representation of the phi, of the phase angle. Well, the phase angle between U of C and U of R is phi. However, the phase angle between U of R and U of C is pi by 2 or 90 degrees. If this is true, this means that this circuit is purely capacitive circuit, and everything else is the same. However, in the analysis here, the theoretical one, we have the same stuff, but what's happening actually? It's the same idea as before, but there is only one voltage. Here the voltage of U of R is zero. It is all zero. Okay? What remains only is U of t is, in this case, will be equal to U of t. U of c will be equal to U of t, and that's actually the voltage of the capacitor, and we have found it previously. We don't need to substitute it, or if we want to substitute it, we can, but put this to be zero. So U of m sine omega t minus phi, and minus phi here is pi by 2, okay, is equal to minus Im over c omega cosine omega t, and then square and add, the same strategy, and then we can find U of m. In this case, R is 0, and in this case, U of m is equal to Im over c omega. However, more than that, the second method, similarly, we are putting here the same idea. Here it is 0, and then we have this one, etc. And in this case, this is pi by 2. That's actually pi by 2, knowing that the current's phase difference is 0, is equal to this one. So in this case, sine Um sine phi is equal to this Im over c omega. Likewise, in this case, we have cosine phi is equal Rim, but here the resistance is 0. So cosine phi is equal to 0 over so it is 0. Cosine phi equals to 0. How much is phi? It is plus or minus pi by 2, or radians, or I am given, C given, omega given, and let me remind you that omega is actually theta prime. It is 2 pi times the frequency, and that frequency, it is in hertz. Okay, and this is in radians per second. Okay, just to differentiate between omega, which is the proper frequency, and the frequency f. However, another exercise is similar to the exercise that I have given you in practice exercise 1. Here the current is equal 5 sine 40 pi t plus phi, and you have to know how much is phi, and I want you to find U of m and phi using two methods. May you have a blessed day and enjoy physics.